All right, so I did split this video up into two different videos. So this second part, you don't need to write all this down again, but just know that we are going to be focusing on this third one with solving inequalities through multiplying or dividing with a negative number. All right, so we're still going to do a couple more examples of just multiplying with positive, is solving one step with positive, but this one's going to focus mainly on learning what do we do when that number is negative. All right, so let's go ahead and talk about this first before we go through some examples. All right, so when we're given a statement that 5 is less than 10, same thing as with the adding subtracting. If I multiply both sides by a positive number, so I'm just going to pick any positive number, let's just say 3. So if I multiply both sides by a positive number, well, and the side that was smaller is still going to remain smaller because since we're being multiplied by the exact same number and they're both positive, this is going to give me 15, and 15 is still less than 30. Because if we're multiplying by the same number and they're both positive, that's a key thing you have to remember here. They're both positive that we're multiplying by, they're going to grow by the same rate. So that means that since they're both growing by the same rate, the one that was larger to begin with is going to be larger to we end with as well. So when we're multiplying by a positive number, nothing changes. Same thing when we're dividing by a positive number. If we're dividing both sides by the same positive number, they're both going to reduce, or if you're dividing by a fraction, depending on what it is, but they're both going to reduce by the same rate, meaning that the number that was larger will remain larger. So if I divide both of these by 2, well, 20 divided by 2 is 10, 18 divided by 2 is 9. 10 is still greater than 9. Even though it's not like it got the distance between 10 and 9 got smaller, it still is greater. So when we're multiplying or dividing by a positive number, nothing changes with the inequality. However, when we go to look and we're doing it by a negative number, well, as we see, 10 is further away from 0 than 6 is, so 10 is greater than 6. That's something that should obviously be very clear to everyone. But when we move in a negative direction, the larger number, and I put that in quotations, but that negative 10 is actually less than negative 6. Because when we're dealing with the negative numbers, the numbers that are closer to 0 are actually greater than. So you see here, we would have 10 is greater than 6. Well, on the flip side, when we go to the negative, negative 6 is greater than, let me write that in the same direction, negative 6 is greater than negative 10. So you see how, in quote unquote, the smaller numbers, when we're dealing with negative, actually are larger than the quote unquote bigger numbers. So since the size of the number or the 6 is no longer still going to be less than, when we go to negative, we need to think about, well, how does that affect this inequality? So if we make an inequality, let's just say same thing, 5 is less than 10. Let's just go through that exact same problem. So 5 is less than 10. Instead of multiplying it by a positive 3, if we multiplied it by a negative 3 both sides, well, now we get negative 15 and negative 30. Well, which number is actually greater now, negative 15 or negative 30? And since negative 15 is greater than negative 30, you see we need to change our inequality, because when we go to the negative side, the smaller number is actually greater than. So that means that we need to flip our inequality. So one of the rules that you're going to have to remember is when we're multiplying both sides by a negative number, and that's what it is. It's the multiplication. It's not that the answer we're getting is negative. It's that the multiplying that we're doing from both sides is negative. That is going to change our inequality. And the same thing holds true when it's division. If it's 20 is greater than or equal to 18, and instead of dividing by positive 2, we divided by negative 2, well, now we would get negative 10 and negative 9. And which number is greater than now? The negative 9 is greater than or equal to that negative 10. So you see, we need to change our inequality when we're dividing or multiplying by a negative number. And the reason is those quote unquote larger numbers that are greater than and are positive are now less than when they're negative. All right, so when we're multiplying or dividing by a negative number, we must flip our inequality. All right, I just wrote this out for you here, so this way you guys can write it down and understand this is super important. So when you're multiplying or dividing, and this keyword by a negative number, you must flip your inequality. All right, so it's not just because we're dividing into or multiplying into a negative number that we flip it. It's only the number that we are dividing or multiplying by. All right, and I'm going to go through some examples with that now so you can understand the difference between them. All right, so now we're just going to go ahead and solve a few problems with multiplying and dividing, and that'll be it for this video. All right, so here are these two examples. I made them to be very close on purpose, so this way we can talk about the difference between when we're dividing or multiplying by a number versus when we're dividing or multiplying into a number. So in both these cases, we have 5x. Well, 5x is less than negative 20, and negative 5x is less than or equal to negative 20. So we're going to go ahead and solve this like we would with a regular equation. We do our inverse operation. Well, since it's being multiplied, we're going to divide each side. And I'm dividing each side by a positive 5. So since I'm dividing by a positive number, we don't flip it, right? Because x is now going to be less than negative 4. Because we're dividing both of these sides by a positive number, we know when we're changing the rate by the same thing on both sides by a positive number, we're not flipping to the other side of the inequality. So it's not going to change that characteristic where the smaller number is now greater than when we move to the negative. So it's not the sign of the number that we're dividing into, it's the sign of the number that we're dividing by. So as long as if the numbers we're dividing or multiplying by are positive, it does not change our inequality. So now we get x is less than negative 4. So the first thing we look at, okay, this inequality is going to be an open circle because it's not equal to. The number that's going to split up my region is negative 4. So let me go ahead and plot this on my number line. And on your tests and worksheets you'll only get one that has like 5 and not 10. So then at negative 4, I'm going to plot the open circle. And that splits my region up into two different regions. I'm going to pick 2 points. Whenever I can, I'm going to pick 0 or 1 because those are the easiest numbers to multiply with. So I'm going to plug in 0 and I'm going to plug in negative 5. So 5 times 0, is this less than negative 20? Well, 5 times 0 is 0, and 0 is not less than negative 20. So no, this side of the region does not work. All right, then I'm going to plug in 5 times negative 5. Is this less than negative 20? Well, 5 times negative 5 is negative 25, and that is less than negative 20. So we know that this side of the region does work. So my graph will go on this side, and that will be my graph. All right, so now when we go into example 4, well, negative 5 times x is less than or equal to negative 20. Well, we need to divide each side by negative 5. So now that we're dividing each side by a negative number, that's going to then bring into that situation where now we're looking at the opposite side of a number line, and the numbers that are larger are now actually less than. So we need to flip our inequality as I showed you before. So now we get x. Now that we're dividing each side, this becomes greater than or equal to, and negative 20 divided by negative 5 is a positive 4. So now whenever we're dividing or multiplying by that negative number, we need to flip that inequality. So same thing, I'm going to now say, okay, 4 is my number that I isolated. So I'll fill in my graph. So 4, 5, 6, 7, 8, 9, and then 3, 2, 1, 0, and negative 1. And then I'm going to have a closed circle because it's equal to, so it's a closed circle at that 4. And that separates my graph into 2 different regions. And now I'm going to plot and pick 2 different points. So I'm going to pick 7 and I'm going to pick 1. So negative 5 times 1, is this less than or equal to negative 20? Well, negative 5 times 1 is negative 5, and negative 5 is not less than or equal to negative 20. That is actually greater than. And then I'm going to plug in, so that means this region does not work. And I'll plug in 7. So negative 5 times 7, is this less than or equal to negative 20? And negative 5 times 7 is negative 35. And negative 35 is less than or equal to negative 20. So that means that this solution does work. All right, so that means my graph is then going to go in this region. Now, you see I plugged this back into my original problem. If you plug it back into your original problem, you can maybe catch some of your mistakes if you didn't flip your inequality, or if you made some mistakes somewhere. So it's important that we plug it back into the original. All right. But I'm going to go through in person some things to make sure that we can go over that we aren't making mistakes and to check our work. All right. And one of the things I didn't say yet in this video clear enough, I don't think, is these give us a range of solutions. So x is less than negative 4. So that means every single number in this direction is going to be a solution. So unlike an equation is going to give us 1 solution, 2 solutions. It's going to give us a finite number of solutions and a discrete number. Whereas when we have inequalities, it's every single number that is less than negative 4. So even in this case, negative 4.5, that is less than negative 4. So that is a solution. 4.01 would be a solution for this one because it's greater than or equal to 4. All right, so it's giving us a range of solutions versus just 1. All right, now there's just 2 more we're going to go through with division. That's it for this video. All right, so these are our last 2 examples we're going to go through. So same thing, x over 3 is greater than 4. So what is happening is being divided by 3, so I need to multiply both sides by 3 to isolate and solve. I'm multiplying by a positive number, so I don't need to worry about changing my inequality at all. So now x is greater than 12. So I'm going to fill in my number line: 12, 13, 14, 15, 16, 17, 11, 10, 9, 8, 7. All right, so now I look and say, okay, it's at 12. It is just greater than, so it's going to be an open circle at 12. And now it splits my graph into 2 separate regions. Now, when I pick these points, since it's being divided by 3, it's smarter for me to pick numbers that are divisible by 3. So I'm going to pick 15 and I'm going to pick 9 because both of those are divisible by 3. So I'm going to see x over 9. Is this greater than 4? Well, I'm sorry, not x. 9. I'm sorry, not over 9. So 9 is the number that I was picking. Sorry. And it's over 3. That's our problem. So 9 over 3, is this greater than 4? Well, 9 divided by 3 is 3, and 3 is not greater than 4. So that means that this choice, 9, does not work. All right, then I'm going to go ahead and plug in. Is 15 divided by 3, is this greater than 4? Well, 15 divided by 3 is equal to 5, and 5 is greater than 4, so that does work. So that means my graph needs to go in that direction, and there is my answer. All right, so this is solving it, and this is writing it as a graph. Now from here, the next one, we have negative x over 3 is greater than or equal to 4. So not only do I need to get rid of this division, but I need to get rid of this minus sign as well. So I'm going to multiply each side by negative 3. Now that I'm multiplying each side by a negative number, I need to flip my inequality. So now x is less than or equal to negative 12. So now I'm going to go ahead and write in my number line. All right, and then I'm going to pick 2 points. Once again, I'm going to pick points that are divisible by 3, so that this way I know that it can actually be divided, make it easier for me. And then I'm plugging it back into the original. So negative of negative 15 over 3, is this greater than or equal to 4? Well, a negative times negative is positive, so then it becomes 15 over 3. And is this greater than or equal to 4? Well, 15 divided by 3 is 5, and 5 is greater than or equal to 4. So I know that this part of our region works. Sorry, I didn't do the first part. So it's going to be at 12, and since it's equal to, it's going to be colored in. So it's a colored in circle at negative 12. So I know that this side of the region does work, all right? And then I'm going to split up into different regions. Then I'll pick our negative 9. So negative of negative 9 divided by 3. Is this greater than or equal to 4? Well, negative times negative gives me positive. So 9 over 3. Is this greater than or equal to 4? Well, 9 divided by 3 is 3. And 3 is not greater than or equal to 4. So this one did not work. So it's still good to still plug it in, because if you made a mistake somewhere along your calculations and you got 2 regions that work, then something wrong happened there. All right, so since the left side is where it worked, we need to go ahead and draw our graph to the left. All right, that is it for this region, for this video, and that's it for this section.